We have a function, f of x equals 4 over x squared minus 9, and we want to determine if this function has y-axis symmetry, origin symmetry, or no symmetry. So we have a test for these types of symmetry that I want to remind you about. And for y-axis symmetry, we know that for a graph to have y-axis symmetry, then you would have a mirror image or reflection over the y-axis. So that means that any point to the right of the y-axis would have a mirror image on the left of the y-axis. This, as I said, is called y-axis symmetry. And any function with this type of symmetry, we give it the name of an even function. We do have a test for even function, and the test for even function is if f of negative x is equal to f of x. And that's demonstrating that statement, f of negative x equals f of x, is demonstrating the same thing that we see in the picture above when we talk about y-axis symmetry. If we think about the ordered pair that's on the right, I would call that ordered pair xy. And because this picture is demonstrating y-axis symmetry, if I think about the other ordered pair, it has to be a mirror image. And for it to be a mirror image, that x-coordinate would be negative x, which is the mirror of x. However, we can see that the two y-coordinates are exactly the same. And that's what we see in this statement here. We see two x values that are mirrors or opposites of each other. And when you look at the y values at each one of those, the y values are the same or equal to each other. So if we want to test to see if something has y-axis symmetry, we're going to calculate f of negative x and see if it comes out to be equal to f of x. Let me also remind you about origin symmetry. And origin symmetry is when we have a mirror image over the origin. And so that means you're going to have a mirror in opposite quadrants. So say if you have a point here, you would have a mirror of that point here in the opposite quadrant. So that's when you have origin symmetry. Any function that has origin symmetry we call odd, an odd function. And we have a test for odd functions, and the test for odd functions is f of negative x equals negative f of x. Once again, this statement, f of negative x equals negative f of x, is showing the same thing that the picture of origin symmetry shows. This point over here, if I label it as xy, because the other point is a mirror over the origin, it will have the opposite x as well as the opposite y. And that's what you see in this equation. You look at the x's and they're opposites of each other. And this y value and this y value has a negative here with the equal, meaning that the y values are opposite of each other. One is the negative of the other. And that's exactly what we see in our picture here. We have the x's being opposite and the y's being opposite. So this is how we're going to test for symmetry. We're going to calculate f of negative x, and we're going to compare it to see if it comes out to be the same as the original function or the opposite of the original function. If it comes out to be the same, we can say that that graph, that function has y-axis symmetry. If it comes out to be the opposite, we can say that the graph has origin symmetry. And if it doesn't follow either of those patterns, then we're going to say no symmetry. We really shouldn't say no symmetry, we should just say neither, because there are other types of symmetry besides y-axis and origin. Okay, so we're going to calculate f of negative x. That's 4 over negative x squared. And negative x squared is negative x times negative x. A negative times a negative is a positive, and x times x is x squared. And I'm not quite sure why I changed this 9 to a 4, but this should be 9. So once we've done that calculation of f of negative x, you want to compare that to the original function. And as I'm looking at these two, they're both exactly the same, and so that's fitting with the definition of even function, where the negative f of x is equal to f of x, the original function. So we're going to say that this is an even function, and we're also going to say that this has y-axis symmetry. In this question it says, use the quadratic function f of x equals 2x squared plus 4x minus 3 to address the following. We want to find any x-intercepts and find any y-intercepts. So I'll start with finding x-intercepts. To find an x-intercept, you're going to let y equal 0. So because it's an x-intercept, it's going to be on top of the x-axis, and the y-coordinate has to be 0. And in our function, f of x is standing for y, so we're going to substitute in for f of x a 0. That gives me 0 equals 2x squared plus 4x minus 3. And I want to solve this quadratic equation. I'll try to factor it. So I would have to have 2x and x to get 2x squared. And to multiply to be a 3, I need these two values to be 3 and 1. So I can try 3 and 1 here. That would give me 3x and 2x. And 3x plus 2x would give me 5, or 3x minus 2x would give me x. And neither one of those would give me the right number in the middle. So I need to try something else. So I'll try moving the 3 over here. And putting the 1 here. That would give me x on the inside and 6x on the outside. If I add or subtract these, that's not going to give me the right number in the middle. So I've tried all the possible combinations. So I'm going to solve this by the quadratic formula instead. So factoring doesn't work. I can always fall back on the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. For this example, a is 2, the coefficient of the squared, b is 4, and c is negative 3. X equals negative 4 plus or minus the square root of 4 squared minus 4 times 2 times negative 3 all over 2 times 2. Now I'll follow order of operations to simplify. This is negative 4 plus or minus the square root of 16. 4 squared is 16. I've got a negative, and a negative, which I'll change to positive. And 4 times 2 is 8. 8 times 3 is 24. And 4 times 2 is 4. I'm sorry, 2 times 2 is 4. Underneath the radical, 16 plus 24 would be 40. And I'll simplify underneath the radical. 40 can be factored. See, 40 is 1 times 40, 2 times 20, 4 times 10, 5 times 8. But I'm going to choose 4 times 10 because of the 4. Square root of 4 is something I can calculate, so that's the factorization I want to use. Use 4 times 10 over 4, negative 4 plus or minus, and now I can simplify that square root of 4 to be 2. 10 is not a perfect square, so I can't simplify that. And then finally, I'm looking, all three of these numbers are divisible by 2, so I can simplify that fraction to become negative 2 plus or minus square root of 10 over 2. So I've got two x-intercepts, negative 2 plus square root of 10 over 2 comma 0, and negative 2 minus square root of 10 over 2 comma 0. So there are the x-intercepts. And then I want to find y-intercepts. So to find a y-intercept, you let x equal 0. I'm going to substitute a 0 in for x. It's 2 times 0 squared minus 4 times 0 minus 3, which is negative 3. So I have a y-intercept at 0, negative 3. Thank you for checking out my videos. Have a great day.